He's touching me with his eyeballs. He's looking at me really hard. Oh, what? Oh, he's here. Oh, and you came up to get it for him?
Yeah, because he wanted to see it. Here.
Oh, here. You might want to give him one of these too, eh? Ramel.
Have
Are you scared of the answer key
problem
for
that he
practice
did
test?
already from the practice test. So take a picture of it.
Sure. Point this guy the right way. I hear that. It's okay.
Well, I know everything. That's good.
All right, guys. So here's the formulas. As always, just let me know if there's something else. And as always, double check if you think I'm writing in the book. All right. So in chapter 7, we got these guys. Look at that new marker, kick ass. Remember this here? If you forget when you're allowed to use Z's or T's, these formulas tell you. I use Z when I know the population standard deviation. I use T when I know the standard deviation sample. And of course, they both require. What do they both require to have happen?
They have to be normal.
It has to be normal, or else you can't do anything, right? And then you got this guy. And they got these guys. Bless you.
Thank you.
All right, so that's chapter 7. Chapter 8, there's nothing really new, but you could put this guy down. You could put this guy down. Z star. Don't even do that to yourself. I mean, the Z-score formula, I desperately hope somebody understands what I mean when it says it never changes. You change the standard deviation, you use the right standard deviation at the right time. It's always my score minus the middle divided by the standard deviation of that situation, right? So the Z-score formula never changes. So that's for tests about a mean. And the T-star formula is the same damn thing, right? Just with an S on the bottom. You still have to change the standard deviation to groups of size and standard deviation, right? You still have to do that. And then you got for tests for percentage. So we stole this from this guy. And if you did the bonus sections, you can go ahead and write down the Z-score formulas from them, from this chapter 9, if you want to. I'm not going to put it up here because that might freak somebody out. You didn't do chapter 9. So does anybody have anything else that should go up there? You could bring all your formula sheets with you, as long as they're nothing that you've lost points on. Please don't put anything else on your formula sheet. Yeah.
You said chapter 9 questions are going to be like bonus questions?
Yep.
Yeah, that's it. Okay. Cool.
So I'm definitely going to have one of the bonus is going to be from chapter 9. So if you've done any of that work, you should be ready for that bonus, if you make it there.
What is that supposed to mean?
It just means if you make it there.
Oh my gosh.
Dude, take it as you want.
That was chapter 10, right?
No.
Or
Chapter 10, we don't even worry about the formulas. I didn't even point them out this semester. I just didn't even want to do that.
so
Chapter 10, we do it all on the calculator, and you have to know the procedures for the calculator. Right? You're going to have to come up and show me the scatter plot with the line on it.
Wait, so we have to actually show you?
Yeah, you have to actually come up to me and show me, on your calculator.
So you just want us to plug in like y equals whatever the sweep is?
Yep. Cool. All right, so anything else besides those? Do you think? That's plenty? Okay. So, where do you want to start? It's totally wide open to whatever you guys want to do.
Can we start off with a problem like on chapter 10?
Yeah, yeah.
Yeah.
All right, let's see. Oh, it's all right. Well, the last time we did the crickets one, let's do one about car repair. Why not? In memory of Tom from Quick and Clack that passed away. So we're going to do the problem in section 10.2. It's number 22. The car repair cost problem.
Beating all fast. I think that formula should freak me out. Because I don't know anything.
We put up here the data so in case you don't have the book, you can start putting it in. There it is. Okay. Can't see that. Is that still blurry?
Can you make it brighter?
Oh, wait a minute. Yay! The autofocus button is just decoration now. Alright, I think it's the best one to do. So that's the first problem there. Now it's a little too bright. Alright. So the car repair cost problem? So full frontal crashes and full rear crashes.
You start off by just entering it to your lists, right?
Yep.
Just like normal.
Yep. So you tell the calculator the whole situation so it's able to do something with it. Now the way I'm going to ask this gives it away, but do you think it really matters which one is list 1 and which one's list 2?
No.
Not really. It'll change what your X and Y is, but it doesn't matter because it's just a relationship between the two. Who cares which one you're putting there and which one you're putting there? Oh, maybe I should put these in.
Why is yours no, oh, but ours not. Oh, yeah, I guess it didn't either. Well, if you graph. Oh, okay.
So has everybody got the data from there?
Mm-hmm.
So I can put all the data, list 1, list 2. Go to stat. Where do you go to get the
Count.
the line? Yeah, calc. And the one with the line equation in? You got all like that? Let's see if we all get that.
Oh, that's easy.
Now, what do you think about that R? Is this a very large sample?
No.
I haven't even told you the cutoff, but what do you think is going to be true about that R value? Is it good enough to show correlation? Yeah, I don't think so either. Very small sample size, and in this case, the required score to show correlation, and again, I'm going to give you this on the test, I'll just give this to you. What was the sample size? How many of them were there?
10.
Thanks. Somebody help me. So for size 10, it's got to be around 0.7.
It's 14. It's
So-
14. I lied.
14. So for 14, it's got to be around 0.6. So see, I mean, it's actually good that that happened. As the sample size grows, the requirement for evidence shrinks, right? It gets easier and easier to pass it because the more confident I am with what I see. So if I got a really small sample, it's got to be really strong evidence. If I got a much bigger sample, it doesn't have to be as strong.
Okay, question. How are we counting these? Because there's 14
Oh.
boxes.
Oh, wait. So how many
But
data
there's
points
7
are there?
different-
7.
There's
Okay.
7 different.
I like it. So there's not 14 data values. One data value is a point. So there are 7 boxes.
So there's 7 boxes. Yes.
Neato. Okay.
I don't
So
even
that's
know why
my-
anyone listens to me.
It almost doesn't matter now. We know it's going to be bigger than 0.6. So for 7, yeah, 0.8. There you go. All right. So do we make it? No. So if I ask you, if I gave you this, and I said, tell me what kind of correlation this is, what would you say? You wouldn't even say weak. You would just say, there is no correlation. Period. So then if I ask you stuff like, what does this correlation mean? You say, well, there is no correlation, so
There is
I
no-
can't tell. I mean, then the answer is very easy. So do you think I'm going to give you one like that?
Yeah.
No.
Oh.
I don't want to let the answer be that easy. Right? So this one's pretty weak. And anybody trying to graph this yet? So if you get the scatter plot by itself, make sure you got your stat plot turned on. And then, of course, if I hit graph right now, you know, I'm going to get the old line from the other day. But do I see any of my data?
Nope.
Why not?
What the?
Zoom. 9. I like it. So there's my data. So now if we put in the line, which was something or other, who's got that?
Negative
Negative
0.18
6.
x plus 2062.
Yeah, okay. Yeah, cool. I like it. So those two up above are really far away, but those distances look to be weighted by all the distances of the other ones below. If I took, now it's really, if you try to talk about what the outlier is here, you could take some guesses and you would probably mostly wrong because there's just not enough data to tell. So if I got more data points and they're all plopping here, then I'd say those two are outliers. If I got more data points and they were all plopping up here, I'd say those 3 are outliers. Well, with such a small sample, I have no idea. Maybe there's a bunch of outliers, I have no idea. Do you guys understand that?
Yeah.
So it'd be really clear if I had a whole bunch of data and then there was a couple dudes up there, I'm like, well, they're outliers. Maybe somebody recorded something wrong, or maybe that's just a weird situation. I can kind of ignore them maybe. If I have a rather large sample, I can tell what the outliers are better. Here, if I take out a few, then it looks better in a lot of different... If I take out those 2, it looks really good. Right? If I take out those 3, it looks... Well, now there's only 4 data points, so screw it. Maybe. But I don't know which ones might be outliers, so I can't take anything out. Okay, so I can't trust that line at all. So if I ask you, predict, let me see, where am I at? Do they have the same 1 to 10 3 car repair costs? I want to see if they have the same. Yes, good. All right, let's look at this question here. So now in 10.3, they talk about the line of best fit. So they actually ask us, find the best predicted repair cost for a full rear crash for Volkswagen, given that the full frontal crash is that. Good Lord. So for $45.94, if the front price was $45.94, they're asking how much would you predict the rear price to be? Now, does anybody remember, if I can't trust my line, are you going to plug $45.94 into my line?
No.
No, because I just said we don't trust it, right? So what's the best guess for what the rear cost would be?
No.
Take the average of the rear cost.
Oh.
Now, how do you do that very quickly? You got them in list 2, don't you? Can't you just do one bar stats? Okay, right. So if that situation happens, you've already got all the data in your lists. Go to stat, count, one bar stats, and I want to do it to L2. So that would be my best guess. No matter what. Since the line that tries to make predictions is not good enough, I can't trust it, I got to fall back on what my best guess always is, the mean. The line just tries to improve on that best guess. If I can't trust it, I got to fall back on that being my best guess, my point estimate. That's the mean. So that would be 16, 14 point, whatever. Okay, maybe. So again, if the R value is not high enough, what does that mean? Why does that make sense visually? Why, if I just look at this, I know the R value is not going to be good? Because my points are not very close to my line, right? So I know that the R value is going to be low. So turn that around. If the R value is low, my data points don't follow my line very well. So then would I use my line to predict where my data points are going to be if they don't follow the damn line very well? No. Good. So if you have a very low R value, if it's not higher than that cutoff that I gave you earlier from that table, I can't use my line to make a prediction. Why would I? The data points don't agree with the line very well. So I can't. So I have to fall back. My best guess always before Chapter 10 was just the average. If you take some random student at Grossmont, what's your best guess for their grade, for their age? Grade. For their age, just tell me the average age, and it's that. That's my best guess. Leave me alone. Right? That's the best I could do. All right, maybe. So if the R was good enough, I could just plug that 4,594 into my equation and see what pops out. Okay, do you want to do another one? Yeah, one more?
Yeah.
Okay. I like that. That was a very decisive answer. All right, let me get one that's going to have a decent R value, just to give it away. Let's see. Udo. All right, this one kind of makes sense why it would be so good. So this is on page 499, number 16, the one at the very bottom there. Can you guys see that? So altitudes and temperatures. So, there very obviously should be a really strong correlation there. Alright, so you guys got that data? Oh crap. Do I have the data? No. Let's see.
The stat again?
Yeah, but if we're using an absolute value, because that just means it's
And then press enter.
inverse. Yeah.
What did you get?
Yes, ma'am. Yeah. Somebody give me a syntax error?
Yeah, that's the part. Really, it's the good.
You got fancy.
So go to, we'll put the
You have a fancy
first one at the bottom. There you go. Just do it. So minus.
I don't think so. This thing.
But just leave it. I hit. I hit zoom in.
Could you show us what to do after this?
Yes.
I use it for
Why? Look, you see what it?
All right. Everybody else okay?
I was using the TI-89.
You hit
Relatively? Okay. All right.
It's like so many.
Let's see.
Got your data in there. You go to stat and count. Number 4. Everybody get this here? All right. This is, we expected this. It's sort of like if I plotted age in months of a fish and how long the damn thing is. I'd expect it to be a pretty good, strong, linear relationship, unless I go too far, because at some point, thank God, it's going to stop growing. The fish that ate New York. No. Somewhere it's going to actually do that. So I'm just going to go there over its growing period, right? This is the same kind of thing. I expect there to be a really strong relationship here. So my slope is roughly
-1.
-3.7. Yeah. And my y-intercept
Wait, what did you just hit? Plot 1?
I hit y equals. So when I want to put in the equation of a function, y equals something, that's why I love that button. You hit the y equals button. So I want to put in there that line, y equals -3.7x plus 72.5. So I'm going to hit y equals -3.7x. Make sure it's the negative button, right? Not the minus button.
Mine looks all crazy.
Plus, now I forgot. Too much I was talking about. 72.5. All right, now of course if I hit graph, we're going to do this whole thing again. So of course I've got to hit zoom 9. Hopefully I've done that enough. You guys remember. So as expected, it's the first time we get to see the nice the x-axis here, right? Because we go negative for my outputs. So that's awesome, man. Even before I would do the line of best fit, I'd go, well, that's going to be damn good. The points are all really tight to the line. So even before we calculate the R, we know we're going to trust this thing. I know the R is going to be really strong. So if I ask you to interpret this R, what would you say?
Very strongly correlated.
I like it, but there's one missing word, of course.
Negative.
Negative. Yeah, because it's falling. Higher we go up, the colder you get. All right. Cool. Yes, ma'am.
I don't know how to fix that. It's not right.
Oh, yeah. Neato. So right there, if you hit mode, you can do all these parametric and polar and all this weird stuff. So you want to go to the funk for function. There you go. So now you can just put it in there.
The last one? The one place one? There's no correlation.
Because the R was too low. It's -0.28 or something like that.
So you're always going to give us like what the R needs
You
to
put
be.
in the equation like how we did it?
Say again?
We don't have to look that up. R. If you're going to tell us R needs to be.
Yeah.
So okay, there's no place we can do it.
No. Yeah. I mean, if we had more time in this class, if it was a 5-unit stats class, we would actually do the whole hypothesis test for the R. But we say, screw that. Let's just do the shortcut on the table. Neato. So I think for stat, here, your plot's not turned on. So hit enter. Turn it on. So hit enter. And then go pick the scatter plot. Enter. Now hit zoom 9. Kick ass. Sure. What was I in the middle of doing? Kate? No? Yes.
That's really strange. It's like,
You know, if I saw the other night, it was like,
Did you get yours? Did I give it to you? Oh, here it is. All right. So if I ask you now, so the same data is in 10.3, more than likely, yes. And they ask you, what would it be at 6,327 feet?
So you would,
What the hell? Okay. These altitudes are in thousands of feet. Took me a second. So if they want 6,327 feet, you're going to put in there 6.327 for thousands, right? 6,000s. Which is good, because what's our range on the data? I don't know if you guys remember this. You can't make predictions for any inputs that are not in the range of what you got. So whatever you observe, you can't predict for anything outside the range of your observations. So thank God 6 point something thousand is in that range, right? So how would I do that in the calculator if I wanted to predict for 6.327? Yeah. Not really. You go to second trace, I like that, value, and then you just put in there, no, 6.327. Bam. So it says it would be about 49 degrees. Or you just actually by hand kind of put that into the equation you got. It's what the calculator does. We put the equation in the calculator, it uses it to get that output. How do you feel so far?
terrible.
Sucks. So, somebody help me out. What was the line of best fit we got again?
negative 3.7.
What?
3.7x. Plus 72.5.
Okay, so that is, and the reason again this has a little hat on it is because it's predicted y values, not actually observed y values. So if I put a data point from my actual data, the answer should come out really close to the actual thing because the points are almost some of them are right on the damn line. So one of our data points was 1037, right? So what do I get if I put a 10 in there? So that's for 10,000 feet. If I'm at 10,000 feet, what can I expect?
35.7.
So if you do that, you get what?
35.7.
35.7. And the actual value is supposed to be 37, right? That's really damn close. And why is that not unexpected? Because our R value was like 0.99 something, right? Do you guys understand? So the further R is from 1 or negative 1, the worse my predictions could get. I could randomly have a few data points land right on the line. But the stronger my R is, the better it's going to be at making predictions. So if I got an R of 0.6 and I put 10 in, this could be, who knows? We did that the other day. It was really kind of far up and really kind of far down, like 9,000 off or whatever for the salary, the income, when we did the education versus income. But that was expected. Our R value was decently strong, but it wasn't like really close to 1. It's going to be off. It averages out pretty good, but for individual values, it would be off. This guy is freaking on it. The R value, I forgot what was it, 0.99?
Yeah.
Yeah. Damn. I mean, that's, you see that and you're like, whoa, I did something wrong. If you see that in the real world. Right? So when I actually correlate, just to give you this whole story, because you guys, I still have to figure you guys out. I correlate all the time for everybody, not just my stats class, the amount of homework all the students do versus what their average is at the end, not including homework. Now, real quick, if I included the homework grade, I would sort of be, it wouldn't really be honest. Because, of course, if the homework grade is a part of my average, and I'm comparing against how much homework you did, it's influencing the grade directly. So I do it without including the homework grade. And I always get R's, and thinking that my classes are normally about 40 students big at least, I get R values around 0.4, 0.5. That's really damn good. For some reason, this is the first semester I got an R value like 0.2. I'm like, this is weird. What the hell's going on? So this is the very first time. It's not a really good correlation. The amount of homework somebody did doesn't really correlate with their grade. So I had some people that did really well without doing any damn homework. And maybe there are people that are retaking this, I don't know. Or I had people that didn't do any damn homework and they're doing really damn well. So maybe they're doing it and just holding on to it. I had somebody once on the day of the final said, we had to turn homework in. Yeah. So yeah, I don't know if that's what's going on. It's just freaking me out. Okay. But that's crazy good. I mean, that's where you go, I did something wrong, because that's crazy. But in this situation, again, if I'm doing fish lengths over time, I expect to get this. If it's not that, then I'm like, what's happening to this poor fish? Something's wrong. Okay, maybe. You guys decent with that? So for the test, you just have to be able to show me the line of best fit and the scatter plot. And then I'm going to ask you a question like, predict for 20, or predict for 4,000, or whatever. And you can just plug it into the dang equation, just like an algebra problem. If I tell you what x is, you can tell me what y is, right? But this is the predicted value for y.
That's the second trace, right?
Yes.
Yeah.
Second trace value, that first one, yeah, cool. All right. Any other questions on correlation, regression stuff, chapter 10 stuff? Yes?
I have a calculator. My line is
If the R is really high, then there is
Oh,
correlation.
y
And
equals?
if the R is
You just
really
forgot to
low,
put the
there
X
is
in
no
there.
correlation.
Yeah, so it comes out to be just a number. Sure.
So if R is really high, then it's likely that there is correlation, and when it's really low, there's no
Yeah,
correlation?
and there's, depending on the sample size, there's a definite value you have to reach. I say definite according to the level of significance, right? So it's not, you don't have to do a hypothesis test, but if you're starting to understand a hypothesis test, you can see that the R I get is some evidence. And the R value I get from the table is like my critical z-score saying, this is how much evidence you have to show. So on this one, I didn't even look it up, did I? Because that's just crazy big. Right?
But that'll always be given, right?
Yeah, I'm going to give it to you
Okay.
on the test. So it's in that table I kept referencing, but I'm just going to tell you what it is. Okay, cool. So you want to move to hypothesis test now? Or, you guys like, not really, dude, but if I'm you, I'd say yes, because then you have to do it yourself on Monday, so
Hell yeah.
am I in here with
Do it.
people? This thing on? Alright, so does anybody have any specific ones that have been bugging the hell out of you want to look at? Or you want me just to pick one? Cool, man. Alright, I'll take that as a pick one. Hey, woo! Hey, woo!
I have a question.
Yeah?
Let's see. Okay. It was in chapter 8. It was 8.2 in the old book, but I was just having a hard time with, how do I know, let's see, I wrote it down. How do I know more? Oh, when it gives you how much area is in the tail, how do I know if that's in the negative area or if it's in the positive?
All right.
I remember
All right, so this is actually, I like this question because on the quiz, the biggest mistake, the part that most people got wrong on the quiz was part C. I think I could count on two hands the number of people that actually got that in the right place and the right value. So, HO is always going to have some kind of equal sign in it. So H1 sets up where my rejection region is. So if I see something like, screw this one. So first, how many tail tests will that be? One. And where must that tail be to make any damn sense?
On the left.
Yeah, it's got to be down here, right? Because in order to show evidence that it's less than 90%, 90% would be what's in the middle. That's what people think the mean is, the average or the expected percentage. In order to show it's not that, I have to be so far down below it to say that it looks like it has to be lower. Right, so if you thought the average age of gross mold was 30, and you went out and took 100 people, and you found out the average age of that was 22, you have to go, maybe I'm wrong. I mean, that's the whole idea here. If you think it's 90%, and you get a sample that's just so damn far below that, you go, looks like I'm wrong. So you would reject the null. You reject your old idea and say, it must be lower than that. I don't know what it is, but I've shown evidence that it's actually lower than that. That's the whole idea. So I had way too many people, putting it up here. You got the right value for Z or T, but it should be down here. And if it's down there, would this make sense to have 2.45? No, because it's down there. So it should be negative 2.45.
Jeff.
Oh, did
Needs
it
to
die?
charge. Yeah.
Oh, poor little dude. Okay. So almost everybody got that, a mistake like that somewhere on that part C. But does that make sense? I mean, so if it was greater than, I'd have the tail up and it would be positive. And what's the only time it's two-tail test? Yeah, if the H1 is not equal to. Cooperate phone. Yeah. All right. Oh, dude. Little vampire. Okay. All right. Does that help you out, Daisy?
Yeah, could you do an example of it, though?
Sure.
Or no, it's fine. Because I kind of have it.
I'm going to do a
and then
whole example, so we'll do that on the way. Let's see. So nobody has a specific one? Let's look at... I don't know why they're fascinated by Chinese babies. There's like a whole thing of that. What is up with that? Okay. So let me make one up kind of based on this one here. So... surveying 732 people. We find 693 of them. Don't open unfamiliar email. You know how often somebody here, a teacher here, actually clicks on a link like, this is your webmaster. And the email address is, who knows. And says, click here to change your password. It's dangerously long that you change, And then we get a little email saying we've been compromised, and then you get all this crap. It's funny. Because we're not government, so it's not going to kill anybody. But we find something, don't open up another email. Test the claim that the percentage of people who don't open that is, what do you want to say, Jeff? 90%. Sure, like I just had. I like it. Okay. Use alpha equal to 0.10. Why not? Okay, so on the test, I'm going to give you all the steps. But notice on the practice test how I give you a problem with all the steps spelled out, and then I give you a problem that says, all right, do it again without using all the steps. Right? For some reason, I have somebody that doesn't do all the steps. Do all 5 steps when I give you that problem. Right? I'm going to have a problem on there with all of them spelled out. You can just reference it. So what's the first step?
Claim.
Yeah, what's the claim?
For 7 people that don't open it, is equal to 90.
Beautiful, right? So very often when you can't tell if it's less than or greater than, it probably isn't either one of those. So the one that's equal to is very quick to miss. If I don't see words like increasing or greater or less, it's probably a two-tailed test. So the claim is it is 90%, so P equals 0.9. So which one is that going to be? HO. I like that. We're all being very careful. And then what about the H1? Does not equal 0.9. So of course, how many tail tests? Two tail tests. Yes, sir.
Why is it P and not mu?
Because this is a test about a percentage.
Oh, okay.
Yeah, so the parameter would be P, right? For the population would be P. Mean, it would be mu. And then the sections that we skipped that we're going to come back to after this, after Thanksgiving, we're going to do testing claims about the standard deviation. So there'll be a little sigma dude here. Right? You should see some of that in section A2, I think. They might reference some of that a little bit. How are we doing so far? Is that good?
How do you know it's a two-tailed test again? I mean, it's a two-tailed
Because the claim is it is 90. So how would you show that's wrong?
if it's above or below.
Beautiful. There you go. Just answering your question. What would the tails have to be? Either way up there or way down there. Two-tail test. I like it. I like it a lot. Apparently a lot of people. I don't know if I want to watch that. So step B now is Z or T, and in this case, what do I have to check?
Normal. Oh, wait, no.
Yeah, I got to check NP and NQ. All right, what's N?
730.
And then what do I multiply that by?
0.9.
Yeah, 0.9, good. And 732 times, what's Q? 0.1. Good guess. That's 73.2, which will make this 69.8? 659.8? Whatever the hell it is, it's bigger than 5. You guys aren't helping me out, so that's all right. I'll get over it. So is that cool? I mean, so just when it's a percentage problem, you use the test that has P in it, right? NP, NQ. When it's a mean problem, then I use the sample size got to be greater than 30. Or like the one on the quiz, I just told you it was normal enough, right? So that's why the sample didn't have to be 30 big. So that means it's normal enough. What about the next step? So we definitely use what?
Z.
Z. When would we use T here?
Never.
Good. Beautiful. Trick question. You don't use T-scores for NPQ problems. It's either normal and I use Z, or it's not normal and I don't do anything. Okay. If you get one that you think is not normal on the test, assume you've made a mistake and keep going and do the whole thing. Trust me. Don't leave the rest of it blank. Right? I appreciate, your your balls on that one, but don't just hold back on it.
It's not recording, so these have to be on the screen.
Oh, the battery's getting low. It's still recording. Yeah, my extra battery needs a battery. All right. All right, so step C now is, yeah, where's the rejection region going to be? So alpha's 0.10. How many tail tests? 2 tail tests. We can use Z scores. So if I look at the T chart, it's okay because I can just go all the way down to the bottom, right? Everybody should have your T chart back.
1.645.
Oh, I should know what it was. Yeah, good. 1.645? Good. So here's how you draw it. 2 tail tests, so you need one down below and one up above. And then how do I say this in words?
Z star is less than
Negative 4.
or greater than reject the lowest part.
Good guess. All right. Is that right?
Yeah.
Oh, thank you. Yeah. That's me. If you don't like that, you have to use it. It's not anywhere else except me. The reason I use it is because we get a Z score here on step C, this z-score, and then we get a z-score that we calculate. And the reason I call it z-star is because then I go back and I put a star on it. Doesn't matter what you call it. All right, so what about this next step? This is the two key steps here. What's far enough away? What's going to show me evidence, and then did we actually find enough evidence? So what do we know from our sample? What's p hat? How do I get that?
693 divided by
Yeah, 693 out of 732.
0.95.
0.9.
47.
47? All right, how's that going? So remember, take p hat stuff out at least 3 places. Does that look good? Yep. Check. Okay, good. And that's all I need. It's kind of funny. I don't really need a lot for this to get going. Z star would then be my score minus the accepted middle
Square root
divided by the standard deviation of this situation. So again, the z-score formula never changes. You can think up crazy as much as you want to, it still doesn't change. So z star would be our score minus 0.9, the accepted middle. From the very beginning we said, okay, assuming you're right, that is the middle. So that's the middle for us. Divide by square root of
0.9.
Good, 0.9. 0.1 over
732.
I always get somebody to use that number instead. Use the whole thing.
Point.
All right, let's see how to put that in there.
947. 9 over.
You want to put there all at one time, which is an excellent idea. You have to put parentheses around the top. Then your square root, you don't close it till you get everything in there. What was it? 7, 12, 32. All right, so I get that. So you guys get 4.24. Oh. So by the book, by the textbook, what would the p-value be?
It would be
What would the book say about anything above 3.5?
is 100.
100%. And of course, you want the amount that's above it. So we got here, basically, right? That's where positive 4.24 is. Way the hell up here. So what percentage is going to be in its tail? Approximately 0. Or the book says 0.0001, but we really know it's about 0%.
Times 2.
Yeah, times 2, exactly. I like that. All right, so if you use the book, you'd actually end up saying the p-value was 0.0002. You double that. All right, we double it because we cut the alpha in half. So to make it fair, we double this back up so we can compare it. How are we doing so far? Now, from just this number here, what can I say? Did we succeed?
Yes.
Yes, we made it into the rejection region, so then we can reject the null, support the high. Cool. So we can reject the null, support the high. And of course, which one? Now, when I go to do the next step, this is the only other time I care about which one was actually my claim. Which one was my claim?
The null.
Yeah, let me put it over here. I got some room here. So this was our claim, so I want to use this language. So then we have succeeded. So we have found sufficient evidence. I like the way they moved it to warrant rejection. To reject the claim. That what?
That 90%.
Yeah, the percentage of people who are smart, who don't open crazy emails, is 90%. So we can reject that notion. In fact, from our study, it looks like it probably is higher. There you go. All right, so then I can follow this up with another study to firm that idea up. How high or is it? Thankfully, that would be the direction I hope it would go.
I don't get why it's reject.
So it's always reject the null or fail to reject the null.
Yeah. What's the claim? Is
The claim was that it is 90%, so that's the null.
Okay.
So then I want to use that language. So what did we manage to do? We managed to reject the null. So we managed to reject the claim because the claim was the null.
Mm-hmm.
Cool.
Yeah.
That's it. Nothing more than that. Don't make it any more than that. Yeah.
What does your last line say?
I don't know. I got tired down there. The percent of people who don't open their email, just take it, just steal it right from you. I just got tired. I'm allowed to do that. You're not.
Is that the only way to figure out the p-value is just by looking at it? Or
Well, if we got I kind of knew it was going to be a big, should have made this a little bit better. But if we would have gotten a z-star of like 2 point, let's make one up real quick. If we would have gotten a z-star here of like
2.36.
2.36, sure, right? And my poor little phone's like, what the hell, man? Did I go too far?
That's good.
Let's try to figure out what the p-value would have been. So here's our critical value was 1.645. We would have gotten here 2.36. So what would this here be? Can anybody help me and figure that out? I know it's going to be less than 50%. So if you try to tell me the p-value here is, like 80%.
Oh, you just look at the area.
2.36. You look it up, and then you do 1 minus.
Subtract.
Yeah.
0.0094.
So you get 0.0094. And then, of course, to get the p-value, you, just for this problem, whenever it's a two-tailed test, if it was a one-tailed test, that would be the p-value. Two-tailed test, you double it. So you get 0.0188. Cool. All right, and what was alpha again? It was 0.10. So again, that is less than 0.10, so it beats that test, right? Okay. This one was almost just too extreme to really make those points about the p-value. All right. I mean, it's totally up to you guys. Remember, it's just review day. If you are ready, you can leave. You don't have to sit there and stare at me, waiting until I say something like I just did.
You gave us
If you have anything that doesn't make sense and that's not clear, then now's the time to bring it up. Yes.
You gave us a paper with with the calculator steps on it, right?
Yes.
Okay. Do you know which one that was?
Oh, from the regression from chapter 10, the one with the beer thing on the front?
Oh, it's this, right?
There you go. Cool. And I gave you one way earlier with a lot more, and that's just a part of it.
Is this just the ones that we need to be able to do all this
Chapter
stuff?
10. There's a much longer list that I gave out.
Here's stapler. It's in a black hole now.
It's up on the website too, I think. Youngji? Or Jungji?
Yeah.
You always have
Yeah, that's for free.
a chance. Yeah. You make corrections. Yeah, okay.
And they can't get it.
I got it.
Yes.
Use that artwork today? Use that artwork today?
It's
That's
not
it,
that bad.
yeah.
I feel like I understand it.
Oh, the answer? Oh, yeah. Not.
That's the only thing that I'm stressed about right now.